Hi friends, good morning. Welcome to the day 2 program of ASTRA 2022 presented by AKKA IAS Academy. Today I'll be discussing few more problems about the speed, distance and time concept, and remaining 3 questions will be on reading comprehension. Okay, so let's begin. So the first question is, in a stream that is running at 2 kilometers per hour, 2 kilometers per hour, a man goes 10 kilometers upstream and comes back to the starting point in 55 minutes. Find the speed of the man in still water. So 4 options have been given here. Okay. So I'll be solving this in the next page. So stream is flowing in this direction. Okay. And the speed of the stream is 2 kilometers per hour. Okay, a man goes upstream, that is opposite to the direction of the stream, rowing a boat obviously. Okay, that speed we need to find out. Okay, in still water, a man goes upstream. If at all we consider the speed of the man will be x kilometer, so in upstream what will happen is x minus 2 is the speed. Okay, and comes back to the same position, that is he also rows back to the downs, he also rows back from going to the end point to back again. Okay, see for example A to B, so A to B is the upstream and B to A is the downstream. So while coming back, if at all the speed of the boat is x kilometers per hour, so then what happens in downstream is the speed of the boat, that is man, plus speed of the stream adds up here, so that will be equal to x plus 2 is the speed. Okay, so also the question states that a man goes upstream and comes back to the downstream in 55 minutes. In 55 minutes. Okay, this is given in minutes, so we need to convert it into hour. So what I will do is 55 divided by 60, because 60 means 1 hour, 60 minutes, that is, so 1 hour. That will be equated to 11 by 12 hour. So time is 11 by 12 hour, and the total distance what he will be traveling is 10 plus 10. Okay, that is total the distance will be 20 kilometers. Okay, so we need to find the speed of the man in still water. So we all have the we have all the given data here. See, I will be substituting here. What is the net speed? Net speed, yes, will be equals to speed of the upstream plus speed of the downstream, that will be equal to x minus 2 plus x plus 2, that will be equal to 2x. See, this is the net speed. Okay, so we have the formula, speed is equals to distance upon time. Okay, so what is the distance here? 20. So what is the time here? 11 by 12. What is the speed here? 2x. Okay, so after solving this, 2x will be equals to 20 into 12 divided by 11. Okay, so this will add up to 12 2 is 24, so 240 divided by 11. Okay, so this will be 2x here, so x will be equals to 240 divided by 22. 11 2s are 22, so 11 2s are 22, so 2 is remaining, so 11 1s are 11, so point, so 11 8s are 8. Okay, 2 1s are 2, so 2 10s are 20, so 1 will be remaining, so 10.9. Okay, x is equals to 10.9, so this is almost I can relate it to x is equals to 11, right? So 2 methods I'll be showing you how to solve this problem. 10.9 can be related to 11 here. Okay, and also we have the formula that here speed is equals to speed of upstream plus speed of downstream. Okay, that is equals to x minus 2 plus x plus 2. So for the x I will be substituting 11 minus 2 plus 11 plus 2. Okay, 11 minus 2 is 9 plus 11 12 13, so 13 plus 9 is 22. Okay, so the speed of the man in still water will be 22 kilometers per hour. Okay, this is the one method of solving. So what is the other method of solving this problem? Okay, with options you need to solve, right? See friends, actually for few questions you can choose from the options itself. Okay, so four different options will be given for a question. So without solving completely, when you choose from the options, it will be easier for you to solve the questions. Okay, the time will be reduced here. Okay, see, for the alternate method I'll be dealing you here is, we know that time is equals to distance by speed. Okay, yes or no? The same concept I'll be applying here. See, in the upstream what happens is, distance is 10 kilometers and x minus 2 is the speed. Okay, so in the downstream, distance is 10 kilometers and x plus 2 is the speed. That will be equated to t. T is nothing but 11 by 12. Okay, see, for this x, what you can substitute, so that upon solving this equation you will be getting 11 by 2. Four options are there from the options. Okay, in the options there are four different options. In the answer there are four different options. Okay, try substituting few problems. Okay, so upon substituting for x equals to 22, this equations will be solved. Okay, this is the alternative method how you can solve the question. Okay, moving on to the next question. A motorboat whose speed in still water is 15 km per hour goes 30 km downstream and comes back in a total 4 hours 30 minutes. Determine the speed of the stream. So this is also actually same kind of question. Okay, see, I'll be solving it in the next page here. So what is the given data here? It is given data here is, speed of the motorboat is in still water. In still water is 15 km. Yes or no? 15 km per hour. So what is the distance here? d1 plus d2. That is upstream and downstream. Okay, that is 30 plus 30. That will be equal to 6 here. We don't know the speed of the stream here. Speed of stream, that is question mark. We need to find out. Let that be x here. Okay, so time taken will be 4 hours 30 minutes. 4 hours 30 minutes. Okay, so totally how many minutes are there? 4 into 6, that will be equals to 240 plus 30 minutes. So 270 minutes. Yes or no? It is as simple as that. So 270 divided by 60, 0 gets cancelled. So this will be equal to 3 2s are 6, 3 9s are 27. That will be equal to 9 by 2 hours. We all got the data here. Okay, time is, total time will be 9 by 2 hour. Okay, a motorboat goes up and down, so total distance will be 60 kilometers. See, that is 30 plus 30, right? 60 means. Okay, so the second method, what I told you in the previous method problem, I'll be substituting here. Okay, so 9 by 2 will be equals to 30 by 15 plus x and 30 divided by 15 minus x. Okay, so for x, when you substitute 5, 30 divided by 15 plus 5 is 20 plus 13 divided by 15 minus 5 is 10. Okay, so 0 gets cancelled. 3 upon 2 plus 3 upon 1, so LCM will be 2. So 3 2 no, that is 6 here. So 9 upon 2. So 9 upon 2, 9 upon 2 gets equals. So when you substitute x equals to 5, you will get the answer as 9 upon 2 equals 9 upon 2. So the speed of the stream will be 5 km per hour. This is as simple as that. Okay, moving on to the next question. A train running at the speed of 56 km per hour crosses a pole in 18 seconds. What is the length of the train? Okay, in the basic concepts of this video, before dealing with these problems, I have explained when a train crosses a platform, when a train crosses a person or a pole. Okay, the same concept you will be dealing it here. Okay, a very simple problem here, only we can be solving it. Okay, speed they have given as 56 km per hour. Okay, so time they have given as 18 seconds. See, this is in hour and this is in seconds. They have asked to find the length, that is nothing but the distance. Okay, what is the length of the train? Okay, that is nothing but distance here. Okay, see here, what I'll be doing here is 56, I'll be converting it into miles per second. Okay, meters per second, not miles per second, meters per second. So what I will do, 5 divided by 18, I will be cross multiplying. Okay, so 2 9s are and 2 2s are 4, 2 8s are 16. That is nothing but 28 into 5 by 9. I will be keeping it as like this only. Okay, this is the speed when converted into meter per second. Okay, so we know the formula, right? Speed is equals to distance upon time. So distance is length, so L is equals to speed into time. What is the speed here? 28 into 5 by 9 into what is the time taken? 18 seconds. Okay, so 9 ones are 9 2s are 18, so 5 2s are 10. 10 into 28 will be 280. So 280 meters. This is the answer here. Option D is the right answer for this. This is a simple question. Okay, so moving on to the next question. A tourist covered a journey partly by foot and partly by tonga. Okay, he is covering a certain journey partly by walking and partly by riding the tonga. Okay, he walked for 90 kilometers and rode the tonga for 10 kilometers. So 90 kilometers he walked and the rest 10 kilometers he rode the tonga. So he spent 4 hours less on the tonga than on walking. If the tourist had reversed the time he traveled by foot and on tonga, the distances traveled on each part of the journey would be equal. So how long did he ride the tonga? Okay, he rode for 6 hours, 4 hours, 2 hours and 5 hours. So I'll be writing the data and solving it in the next page. This question can be solved in 2 different methods. I'll be telling both the methods. Okay, one is a simple method through options and one is the equation method. Okay, see, in the first condition they have told that 90 kilometers he'll be walking partly journey and he'll be riding tonga for 10 kilometers, right? This is the condition here. Okay, so what they are telling is, if at all while riding tonga he takes 4 hours lesser than what he take for the walking time. Okay, so then if at all we consider it as x here, and this will be x minus 4 here. Okay, see, it's as simple as that. So speed will be equals to distance traveled divided by time taken, here 90 by x, and in this case what will happen is speed will be distance traveled 10 km by x minus 4. Till here you got it, right? This is the condition till here. Okay, so after that what they are telling is, if at all it is reversed, okay, if at all he reversed the time traveled by the tonga to time traveled by the walking, so then the distance traveled by tonga will be equal to distance, if at all when it's reversed, the distance in the second case, distance traveled by tonga will be equals to distance traveled by walking. Okay, this is the conditions they have given here when the time is reversed here. Okay, so we know that distance is equals to speed into time, right? Distance is equals to speed into time, and here also distance will be equals to speed into time. So what is the speed by walking here? Actually what is the speed of walking here? See, I'll be considering this as walk and this as tonga. Okay, walk and tonga. So what is the speed of while walking? 90 by x, right? Speed will be 90 by x. What is the time taken? Reversed time, x minus 4, not x, when it's reverse time. Okay, this will be equals to, what is the speed here? 10 divided by x minus 4. This will be equated to into what is the time? Reversed time. See, this is the equation you need to form here. Okay, when distances are equal, we are equating speed and time and speed and time here. Okay, speed is the speed while walking and time taken the reversed time, x minus 4, and speed is speed while riding the tonga and the reverse time, x here. Okay, we will be solving here. Okay, this is the equation what we have got here. Okay, so 90 by x into x minus 4 will be equal to 10 upon x minus 4 into x. See, 90 into x minus 4 upon x will be equal to 10x by x minus 4. So here x minus 4 will go this side. Okay, 90 into x minus 4 whole square will be 10x square. Okay, so what we can do is, okay, x minus 4 whole square will write here and x square will take it down here. So 10 divided by 90, that will be equal to 1 by 9. Okay, so square is there. So this can be summed up as x minus 4 upon x whole square will be equals to 1 by 9. So 9 is 3 square, right? So we can write it as x minus 4 upon x whole square will be 1 by 3 whole square. So this square gets cancelled, and x minus 4 by x will be equals to 1 by 3. So 3x minus 4 3s are 12, that will be equal to x. So 3x minus 3x minus x will be 12. So 2x will be 12, x will be 6 here. So what is x here? What we have taken x? We have got x equals to 6, right? So what is x here? Actually the time traveled by walking here. X is equals to 6. Okay, so 4 hours less means x minus 4. X minus 4 means 6 minus 4, that is 2 hours. So while riding Tonga he will be taking 2 hours. This is the equation method while solving the problem. Okay, this is the equation method. Okay, when you see, this is a bit longer method, right? But you need to know how to write the equations. The answer will be obvious. Okay, if at all you put on the equations in a right way, the answer will follow. Okay, so there's also a simple method to solve this problem. See here. Okay, going through the options. See, when you see option 2, that is 2 hours, the conditions match, right? If we rode for 2 hours, okay, see here, walk is there and Tonga is there. Okay, walk and Tonga is there. So walk is 90 kilometers and Tonga is 10 kilometers. Okay, see, if at all he rode for 2 hours, so what will be the speed? Speed will be 5 kilometers per hour. See, in 2 hours he has covered distance 10 kilometers. Okay, speed will be 5 kilometers per hour. If he rode for 2 hours here, 4 hours will be more here. Totally 6 hours he will be walking here. Yes or no? See, 90 divided by 6 will be what is it? 15. Okay, it is 15 kilometer per hour, and this is 5 kilometers per hour. See, it is obvious that, okay, when the condition have been reversed, if we interchange that, then we will get 15 into 2, that will be equals to 30, and also 5 into 6, that will also be equals to 30. See, this is in few steps only you will be getting the answer, right? So getting answer is most important, but how you get the answer, how you go to the answer is also very much important in CSAT. You need to minimize the time, okay, by solving the questions. Okay, so when you get well versed with the formula method, then you can switch on to any other methods. Okay, when you are comfortable with one method, then only you switch to any other methods which is convenient to you. Okay, so for a single question there are many options, there are many methods which you can use to derive to the answer. Okay, so kindly make that your conceptual clarity is very much clear. So then switch on to the other methods. Okay, moving on to the next problem. A train 100-meter long is running at a speed of 30 kilometers per hour. The time in seconds in which it will pass a man standing near the railway line is. It is also a very simple problem. What they have given here? Distance is 100 meter, speed is 30 kilometer per hour. Okay, we also know that T is equals to D upon S. D is 100 meter and S is 30 kilometer per hour. So these SI units are very much important, right? When you solve the problem, these SI units are very much important. Okay, so this will add up to 100 meters divided by 30 into what we are doing here, we are converting kilometer per hour into meters per second. So 5 by 18. It is as simple as that. Okay, so meters per second is here, then how to solve this? Okay, 15s and 9s. Okay, 15s and 9s. 2 into 15 and 2 into 9. That is as simple as that. Then 100 divided by 15 into 5 divided by 9. So this will adds up to 100 into 9 divided by 15 into 5. So 5 1 times, 5 20 times, 5 3 times, 5 3s are 15, 5 4s are 20, and 3 1s are 3, 3 3s are 9. See, 4 3s are 12. So 12 seconds is the answer here. Okay, time taken will be, T will be 12 seconds. This is the answer. Option A is the right answer here. Two trains start at the same time from A and B, proceed towards B and A at 36 kilometers and 42 kilometers respectively. When they meet, it is found that one train has moved 48 kilometers more than the other. What is the distance between A and B? See, I'll solve it in the next page here. This is the diagram I'll be drawing here. Station A, station B. So it is 36 kilometer per hour, and this is moving at 42 kilometers per hour. Okay, so at some point they will meet here. Okay, let us take it as C. So what is the distance will be here from here to here? So it is given relative, right? If at all from A to C we consider it as X, and B to C will be X plus 48. Okay, 48 kilometers more they have given here. Okay, so what we need to do is we need to equate the time here, because distance is different here and speed is different here, whereas time taken is same here. Okay, so T1 will be equals to T2. So we need to equate the time when trains are meeting. See, the train is they are meeting from two different points. Okay, so when trains are meeting, we need to equate the time here. This is the star mark. These conditions you need to remember. Okay, I have explained it in the basic concepts in the video. Okay, so T1 will be D by S and T2 will be also D by S. Okay, D2 and D1, S1 and S2. So for your sake, okay, X by 36 will be equal to X plus 48 divided by 42. See here, this I'll be solving here. So X by 36 will be into, I'll take up the 42 here, upon X plus 48 will be equals to 0. So 2 1s are 2 18s are 2 2s are 4 2 1s are 2 3 7s are and 3 6 are 7 by 6. Okay, so 7x will be 6x, 6 into x plus 48 I'll be written, that will be equal to 0. Okay, 7x will be now 6 into x plus 48. Okay, so 7x minus 6x will be 48 into 6. This can be written as, okay, so x will be 48 into 6. So x is equals to 6 6 are 6 is a 48, 8 4 will be carry, 6 4 24 28. So, okay, 288. X will be equal to 288. So what is x here? The first distance. Okay, total D will be, total distance will be x plus, so another is x plus 48, right? So 288 plus 288 plus 48. Okay, so then 288, so 488 plus 88, so plus 48. Okay, this will be 8 16 4, then 2, then 6. Okay, So total D will be 624. Distance between two stations is 624 kilometers. Okay, this is the answer for that. It falls in the option C. It can also be solved in another method. Okay, this is the formula method. It can also be solved in this is the conventional method. Actually, there's a formula method will be simpler here. Okay, it's a conventional method of solving. So we know that formula, right? When two trains are meeting, the formula will be D into S1 plus S2 divided by S1 minus S2. Okay, D is 48. So the difference in the distance of difference is 48. So 36 plus 42 whole divided by 36 minus 42. 48 into 78 by 6. So 48 into 6 ones are 6 plus 1 is 1, 6 is 18. So 48 into 13, not 133, 48 into 13, that also will be equal to 624. Okay, this is the formula method. The very important thing is this, you need to know the substitution. Okay, the substitution in the formula method is very much important. First you get a hold of this traditional method. Okay, then only you will be understanding how this formula method works. Okay, moving on to the next question. The distance between two stations A and B is 300 kilometers. A train leaves station A at the speed of 30 kilometers. At the same time, another train departs from station B at the speed of 45 kilometers. What will be the distance of points what will be the distance of points where both the trains meet from point A? Okay, this is the question, similar to the previous question. Okay, I'll be solving it in the next page. See, so from point A to point B they have been given here. So A, this is 30 kilometer per hour, somewhere here 300 kilometers, and this is 45 kilometer per hour. Okay, we are assuming it is. So one more thing I'll be doing here. Okay, see here. So if at all you consider it as x, this will be 300 minus x. Yes or no? If at all this part you consider it as x, the other part will be 300 minus x, total distance. Okay, now we will be equating. Okay, t1 equals t2. So time will be equating here. Okay, as trains are moving to each other. Okay, they are moving to each other. So t1 will be d by s. That's also d by s. So d1 s1, so d2 s2. So here d1 is distance traveled is x by 30, speed is 30, distance is x, and d2 is 300 minus x by 45. Okay, so this will be cancelled. Before cross multiplying only we can do 2s and this is 3s. Okay, so 3x will be 600 minus 2x. So 3x minus 2x will be 600. So x is, this will come here, right, plus, say I have written wrong here. Okay, so 5x will be 600, x will be 600 divided by 5, 5 1s are 5 2s are, so x will be 120. This is a simple problem. Okay, option A is the right answer for this. In the formula method, how we can do the formula method? See, in formula method I'll be writing the formula here. When trains are coming to each other, so they are crossing each other, so then the formula will be S1, when distance is not given, distance is unknown, so this formula will be using S1 D plus S1 T whole divided by S1 plus S2. Okay, this is the formula here, where this T, that is time difference. If at all two trains are starting at two different time interval, then the time difference is there, no? That is the small t here. Okay, so what we have, S1 here is 30. So total distance they have given here, okay, that is 300 plus 30. The time difference is 0 here because they are starting at the same point, same time. So 30 by 45. So when you solve this equation, 30 divided by 300, 30 into 0 is 0, 30, 75. Okay, so 3 3s are 9, 2 zeros and 1 zeros, whole divided by 75. So upon solving this, I'll be getting 120 is the answer here. Okay, this is the formula method and the same method. Okay, other is the step-by-step procedure. Okay, so we'll move into the next question here. So from this is the passage here. Our urban bodies cannot possibly ensure sustainable delivery of water in our cities unless financing mechanisms are put in place. Water delivery requires heavy investment in collecting it from a natural source, treating it to make it potable, and laying a distribution network of pipes for delivery to the users. It also requires investments in sewerage infrastructure and sewage treatment plants so that the sewers can carry out the wastewater to these plants to ensure that no untreated sewage is discharged back into the natural water bodies. If our cities were rich enough to to meet the entire cost, water could be delivered free. They are not. Okay, this is the passage here. See, urban bodies, they are talking about the sewage treatment plant and what can be the possible solution for that. If at all our cities were rich, so then this problem, the delivery of water could be free. Okay, if at all they were rich, the possible option they are speaking here. Okay, so urban bodies cannot possibly ensure sustainable delivery of water in our cities. So it is for sure that they cannot possibly, okay, they cannot possibly ensure sustainable delivery. It is telling 100% sure that they are not able to sustainably deliver water in our cities because the financing mechanisms are not in place. Okay, the financing, the cost, what they need to push in, they are not in place. Okay, so what the cost they need to push in, no, what it requires, the cost is required for what? See, water delivery, heavy investments, and networking of pipes, sewerage treatment investments. These all the gist of this passage here. Okay, we'll see the question now. What is the most logical and crucial message conveyed by the passage? Okay, option A, B and C, D are given. A, B, C, D are given here. Okay, option 1, urban local bodies must recover cost through user charges. See, the passage is telling that urban local bodies must recover cost through user charges because the passage is most logical and crucial message. Okay, this can be the possible option. So we will explore the next option as well. Okay, urban local bodies are not efficient enough to meet the water requirements of our cities. See, the passage is not telling that urban local bodies are not efficient. Okay, but the passage is telling that for urban local bodies to make this sewage treatment and all the treatment, the required financial inputs are not correct. Okay, it is not sufficient. Okay, so then the funds deficiency is mainly highlighted here than the efficiency of the urban local bodies. So option B can be negated here. Water storage shortage in our cities is a perennial problem that cannot be solved. So perennial problem, this nowhere in the passage we can see that water shortage is there and it's perennial problem. So this can be also negated. In the view of the water crisis in our cities, there is an urgent need to limit the population. No, so population also they have not told. Okay, they have not talked about the population. So urban local bodies must recover cost through user charges. This may be the possible crucial message what the passage needs to convey. Okay, what the passage is conveying is there is a huge financial crunch which needs to be financed so that the the urban local bodies can build up better infrastructure so that we get the water efficiently. So option A is the most probable right answer here. Moving on to the next question. With reference to the above passage, the following assumptions can have been made. Okay, assumptions. In the previous video, I talked about the assumption, right? What do you mean by assumption? What do you mean by inference? Okay, the first statement is rich cities only can ensure sustainable delivery of water. Oh, rich cities can enable. No, actually, the assumption cannot be made here. Okay, if at all for urban local bodies, whenever the funds can be financed efficiently, those urban local bodies will function efficiently, right? So the second option will be checking here. Sustainable delivery of water in cities means much more than supplying water to households. Sustainable delivery of water they have told here. Sustainable delivery of water in cities means much more than supplying water to the households. Okay, much more means sewage treatment plants, that infrastructure, sewage treatment. Okay, this is much more here in supplying water to households. Sustainable delivery of water means these all should be required here. So option 2 is right. Okay, option 2, not both 1 and 2. So option B is the most probable option here. Okay, moving on to the next question. In India, agriculture still engages about half of its workforce and about 85% of its farms are small. 85% of its farms are small and marginal. Okay, compared to China and Vietnam, which have experienced fast structural and rural transformation, India's story is of slow transformation. Okay, as a result, poverty reduction in India was at much slower pace during 1988 to 2014 compared to China and Vietnam. India's poverty reduction was slow during 1988 to 2005, but during 2005 to 2012 it accelerated dramatically, almost 3 times faster than the during earlier period. What did India do during this period? Research reveals that relative price scenario changed significantly by more than 50% in favor of agriculture in the wake of rising global prices. See, research reveals that the relative price scenario, this is important, changed significantly. This boosted private investments in the agriculture by more than 50%. So private investments inflew. As a result, agriculture to GDP ratio touched 4.1% against during 2007 to 2012 against 2.4% in 2002 to 2007. The net surplus of agri trade touched $25 billion in 2013 to 2014. Real farm wages rose by 7% per annum. All this led to unprecedented fall in poverty. Okay, this is the passage here. Okay, in India, the passage speaks about the agricultural practice since ages to present days. This is the first point we can infer from the passages here. Okay, in earlier stages it was very much poor because the input what in the later days agriculture got through financing from the private investment was not there. Okay, so this is the major input. Okay, why the agriculture was poor, why the agriculture was transforming slowly in the earlier phase to later phase. Okay, so then also the data has been given. So the agriculture to GDP ratio touched 4.1% and during 2000 to 2012 against 2.4 into 2.4% in 2002 to 2007. So these are the data have been given. So actually the whole passage is talking about the transformation of agriculture in earlier phase to later phase because of the change in significant, because of the what relative price scenario, because of relative price scenario. This is the main theme of the passage here. Okay, we will be solving the question here. With reference to the above passage, the following assumptions can be made. Assumptions again: structural and rural transformation is impossible when farms are mainly, see this is impossible is wrong here. Structural and rural transformation was happening slowly in the earlier phase compared to the later phase. This is the passage what it is saying. Okay, structural and rural transformation is impossible when farms are mainly small and marginal. This is, it was happening slowly. Okay, it was not happening at all. This is not the, this is the statement telling, but the passage is telling it was happening slowly. So one can be eliminated. So one can be eliminated means one option gone. So rest three are there. So a good price incentive can trigger investments in the agriculture. See, this is what happened in the agriculture, right? A relative price influx, that scenario, after that only investments triggered in the agriculture. So this can be a good option. So 2 and 2 are there. So we shall check the third option. India needs to build value chains for high value agri products like livestock. No livestock and horticulture they were talking. Okay, so the third option can be eliminated. So three eliminated means the most probable option will be B, which we shall check the fourth option also. Higher global prices of agriculture commodities are essential for India's poverty reduction. Okay, if at all the global prices rises in the agriculture commodity, the same happens here, because the demand will be boosted here. So for the it is essential for India's poverty reduction is the most probable option. Okay, hence option B is the right answer here. So this is the last question for today's video.